afternoon. Oh, got to move my mic to my face. This is Science 9 Enriched, and we are looking at some more polyatomic ions, just getting introduced to them. Today, the polyatomic ion we're going to look at is acetate. We'll be looking at others, but this is the one we're going to start with. Acetate has a funny formula. It is written as CH3COO minus, and I often get students asking me, why don't we simplify it by writing it like this? C2H3O2 negative. And the fact is that we can write it like that. Both are correct. The reason that we write it as CH3COO rather than C2H3O2 is because it more accurately represents the structure. So if you look at the picture just down here, you can see we have a carbon and it is attached by what kind of bonds? To the hydrogens. What kind of bonds are those? Between nonmetal and nonmetal, those are covalent bonds. And we have a covalent bond again between the C and the C, and the C and the O, and the C and the O. Okay, so you can see we have a nice little CH3 structure here, and then we have a COO structure, and the negative charge actually resides on the oxygen end. It's sort of spread out over the two oxygens. That's way more than you need to know for grade 9, but that just gives you the reason why we write it as CH3COO rather than simply as C2H3O2 minus. However, like I said, both are correct. So let's look at sodium acetate. This is a compound. It is made of the sodium ion, Na+, and the acetate ion, CH3COO-. And if it's made of those two ions, what kind of a compound is it? If it's made of ions, it is an ionic compound. And although there were covalent bonds within the polyatomic ion, and I'm just going to start abbreviating polyatomic ion as PAI because it's really long to write polyatomic ion. So there are covalent bonds within the polyatomic ion. What kind of bonds do we have in between, so just in between the sodium ions, which are those purple ones, and the acetate ions? Okay, the question is, what kind of bonds do we have in between? All these little yellow highlighty bits are showing our bonds here. What kind of bonds are in between the sodium ions and the acetate ions? You can pause the video and answer that for yourself. I'm going to answer it now. They are ionic bonds. What kind of bonds are between ions? Oh my gosh, they are ionic bonds. Okay, and this is an ionic compound made from differently charged ions, a cation and an anion. I want you to take note of the ratio of the sodiums, the purple ones, to the acetates. The ratio is a 1-to-1 ratio. For every one sodium, there's one acetate. Why is that the ratio? Answer that for yourself. Pause and answer it. Why is the ratio 1-to-1? Well, we have a positive charge, +1 charge on the sodium, and a -1 charge on the acetate. And if we want the overall compound to have a charge of 0, One of each is perfect. Yeah? If we have a +1 and a -1, then our overall charge is 0. And remember, all compounds should have an overall charge of 0. Another thing I'd like you to notice about this formula is that when we write it, I'll rewrite it down here a little bigger, NaCH3COO, there are no brackets here, okay? If you remember from last day, back when we were, say, having ammonium oxide, we had to put the ammonium in brackets. The reason we did that is because there were 2 of them. So if you have more than one of a polyatomic ion, you put it in brackets. But if you only have one of a polyatomic ion, like here, we only have one acetate, there's going to be no brackets. Okay. Let's look at a few others just to sort of hit that home. Calcium acetate. Calcium is in group 2, so its charge is 2+. So in order to, balance that 2+ charge, we need to have a -1 and a -1 for an overall charge of, negative charge of 2 negative. 2 positive and 2 negative makes a neutral compound. Because we have 2 of the acetate ion, let's make this a little bigger here. Because we have 2 of the acetate ion, we put it in brackets and we put a 2 on the outside. Okay, what if we put acetate with iron? And because iron is in the red zone, it is a multivalent, we need to tell you what kind of charge iron has. Because we have a 3 here, that means that it is iron +3, or iron 3+. If we have 3 positives, we also have to have, each of these is -1, we need to have 3 negatives. Okay, because our 3 positive and our 3 negative, if we add those up, our overall charge is going to be 0, which is what we want. And because we have more than one of the polyatomic ion, we need to use, what do we need to use? Brackets, because it means we have 3 of that entire group. Okay, I don't just have 3 of the O's, I have 3 of the entire group. And finally, here's one where we have silver, which is plus, or +1, and so we only need one acetate to go with it. And you'll notice here we have only one polyatomic ion. Only one polyatomic ion. And so we do not use brackets. Do not use brackets. So brackets only when there's more than one polyatomic ion, no brackets when there's only one. Don't worry, we're going to have a whole section on writing formulas, and we will review all those brackets there. This is just introducing the concept of brackets to you and when to use them. Okay, next on our list is the carbonate and bicarbonate ions. And the reason that I wanted to put these ones in here is because you can make a relationship between a something or other 8 ion and a bi something or other 8 ion. It's not just going to be carbonate, it's going to be other things as well. Take a look and see if you can see the difference between CO3 2- and HCO3-. Okay, pause for a moment and list 2 differences that you see between those 2 ions. 2 differences. Okay, hopefully one of the things that you notice that is different is that this one has one more H. Okay, and the second difference is that over here we have a 2 minus charge, and over here we have a 1 minus charge. Now what's happening is if you go from the carbonate ion and you take a CO3, 2 minus, well, that's not a minus, that's a plus, 2 minus, and we add to it a hydrogen ion. And remember, hydrogen is in group 1. It's got its 1 valence electron, so it loses a valence electron to become plus 1. Take a look at what happens if we put our carbonate and our hydrogen H plus together. We end up with that extra H, okay, on our HCO3. And if we take our total charge here, we have a 2 minus and we have a positive. So 2 negative plus 1 positive. That gives us 1 negative. Okay, and look at that. Oh, 1 negative. Okay, so that is how we take a something or other 8 ion and turn it into a bi something or other 8 ion. In this case, carbonate, if we add an H plus, it becomes bicarbonate. Oops, should have just written carbon there. Bicarbon? I'm having problems writing. Here, let's try that one more time. Carbon, bicarbonate. Now, do you need to memorize this? No, you don't. You're going to have a lovely sheet. If I was able to photocopy it for you, it would be green, but it will be available on our team site after this lecture, okay? So you don't need to memorize it because all you'll do is you'll look on your table of common ions and it will say carbonate. It will be under C for carbonate, and it'll say CO3 2 minus. You're going to look under B for bicarbonate, and you're going to see HCO3 minus. Okay, so don't worry about memorizing it, but just be aware that the relationship between an 8 and a bi-8 ion is that the bi-8 ion has 1 extra hydrogen. Okay, this will come in handy if you're taking any advanced chemistry courses, just to be able to know how the ions are named, sorry. One other thing, bi-8 ions also have a different name. They can be called, instead of bicarbonate, you could call it hydrogen carbonate, which makes sense because we've added a hydrogen onto our carbonate ion. When you get your table of common ions, what you will see is you will see the ion listed, HCO3 minus, and you'll see its name. It'll be given like this. Oh, sorry, I got it wrong way around. It'll be listed like this. Hydrogen carbonate, and then there will be a comma, and it will say bicarbonate. So if you have a compound that contains this HCO3 minus ion, you get to choose one name. Don't give it both names, okay? You're either going to use hydrogen carbonate or you're going to use bicarbonate. Hydrogen carbonate is the more official name, bicarbonate's the more common name. So if I gave you a compound like lithium bicarbonate, you could also name it lithium hydrogen carbonate. But whatever you do, do not name it lithium hydrogen carbonate bicarbonate. That would be like if somebody's name was Catherine and they went by the nickname Kate, that would be like wandering around calling them, "Hey, Catherine, Kate, how you doing?" Or if we had somebody whose name was Robert and he went by Rob, it would be like wandering around saying, "Hey, Robert Rob." We just don't do that. You pick either one or the other, not both. Okay? So just looking at our balanced charges, we'll take first a look at the carbonate compounds. That's the carbonate without the extra hydrogen. Carbonate has a 2- charge. Lithium is in column 1, group 1 of the periodic table. So it has 1 valence electron. And so when it becomes an ion, it loses that 1 valence electron and it becomes +1. In order for a compound to be neutral, we need to have 2 lithium ions for every 1 carbonate ion. That gives us a total of +2 to balance out the -2. And we write that in our formula by saying that there's Li2 and then CO3. And you'll notice there's only 1 of the polyatomic ion. So we do not use brackets. No brackets. My Chemistry 12 students this morning called them brackies, and they seem to like that. So every once in a while, maybe I'll call them brackies just for fun, throw that in there, lighten up the mood a little bit. Okay, now let's have a look at the lithium bicarbonate. Now remember carbonate, CO3, 2-, when we add on a hydrogen, H+, we're going to end up with our bicarbonate, HCO3-. And it only has a -1 charge, and because lithium is +1, the charges already equal out to 0. The overall charge is going to equal 0, which is what we want. So we'll have lithium HCO3, and these start to look a little funny, okay? But what you always have to realize is there's always just going to be 1 cation. That's our cation. And all the rest of it is our 1 polyatomic anion. So when you're naming it, you'll just name your cation lithium. And you will look on your polyatomic ion, common polyatomic ion chart, and you'll see HCO3, and you'll see its name, and you'll say, oh, it's hydrogen carbonate. So its name is lithium hydrogen carbonate, or, of course, lithium bicarbonate. Okay, let's go over to barium carbonate. Barium is in group 2 of the periodic table. Therefore, it has 2 valence electrons. Therefore, it's going to lose 2 electrons to become an ion, have that stable full shell. And therefore, its charge is +2 when it is an ion. Carbonate has a charge of -2. How would you know that? Do you have to memorize it? No, you don't. You will just look it up on the table that I will post along with this video. Okay? So we have a 2+, we have a 2-, and that means that we have just 1 of each. So that's barium carbonate, just 1 carbonate, therefore no brackets, no brackies. Okay, there is our cation, and there is our anion, barium carbonate. Barium bicarbonate, barium is 2+, so we now need to have 2 of the bicarbonate ions to give us a 2- charge altogether. So 2+ and 2- overall gives us a 0 charge. And this time, because we've got more than 1 of the polyatomic ion, we have to put it in brackets and say we have 2 of that whole group. There is our cation, and there is our anion. Remember, the cation is always first, and the anion is always second. Okay, and finally, for today, we will look at tin. And because tin is in the red zone, if it is in the red zone, that means that it is, what's that word that starts with M? Multivalent. What does it mean to be multivalent? If a metal is multivalent, that means that it has more than one possible charge, which means that we need to have a Roman numeral to tell us what that charge is. And 1 before 5, I before V, is 4. Okay, so there's our 4 positive charge. Carbonate is 2 minus. So 2 times 2 gives us 4, so that's -4 altogether. And here we have 2 polyatomic ions, so we need to have the brackets. Okay. Tin for hydrogen carbonate. What's our other name for that? It would be tin for bicarbonate. Okay, so we've got our 4 plus. Oh my goodness, we're going to have 1, 2, 3, 4 bicarbonates to give us a 4 minus charge to balance out that positive 4. And so because we've got more than one polyatomic ion, it goes in the brackets. And then we have a 4 on the outside to say we have 4 of that entire group. All right, one last question, and that'll be it for today. If SO4, oh, there's a typo here. My apologies. This should be a 4 here. If SO4 2 minus is sulfate, what is the name of HSO4 minus? Okay, pause the video, answer that for yourself. Even write it down. Oh my gosh, writing down activates all kinds of different neurons in your brain and helps you remember things better. Okay, so the answer to this is if we have an extra H, okay, and we have one less negative charge, because if we take SO4, 2 minus, and we add a hydrogen to it, we're going to get HSO4, and then a -2 and a +1 gives us a -1 altogether. This is going to be named either bisulfate, okay, HSO4 minus is either bisulfate, or you could name it hydrogen sulfate. And by the way, if any of you are wondering about the pHs in sulfur, you could also write this as bisulfate and hydrogen sulfate. The pH is British, the F is American. I tend to use the pH, but if you write an F, it's also totally fine. It's just a different spelling. Okay, and finally, last question of the day. If S2 minus is sulfide, what is the name of HS minus? Please give me 2 names. Pause the video, write them down for yourself. HS minus is going to be bisulfide, or it's going to be hydrogen sulfide.